All right, next up, we're going to take a look at alkanes and alkenes. And so what we're looking at here, first of all, to start is the CH bond. So we're not looking at the carbon-carbon bond, but we're looking at the CH bond. And in terms of the alkanes, almost all of our molecules have this. And so it's not very useful, because it's going to show up in almost every single spectrum. Although if you don't see it, then that tells you that something interesting is going on. The more useful component here is something like an alkene carbon-hydrogen bond, right? So we're talking about, here's this carbon-hydrogen sp2 hybridized bond. This occurs above 3,000, whereas the alkane occurs below 3,000. Right, and so you can see this is what it's telling you right here, right? Alkenyl above 3,000, alkyl below 3,000. In addition, the carbon-carbon double bond will also have a peak from about 1680 to 1640. However, this peak is moderate/variable. And so it's not all that useful because it can get a little bit tricky. So I wouldn't rely on that too much. But this whole, alkyl versus alkenyl CH bond is somewhat useful. So for example, in this molecule of ethanol, we have no double bond. And actually, if you draw a straight line at 3,000, you'll see that all of these are below 3,000. Right, you can see that this biggest peak is at 2981. And so you can tell that you have no alkenyl bonds. If you do have an alkenyl bond, right, something like this, for example, in 1-hexene, what you'll see is this little kind of shoulder here, right? You see how there's this peak is above 3,000, right? That tells you that alkene is present. And then the rest of this big old peak right here is the rest of the molecule with all these other CH bonds. Of course, there are molecules without any carbon-hydrogen single or carbon-carbon single bonds, something like benzene here. All of these are sp2 hybridized carbons. And so you can see that reflect in the IR spectra where all of these are above 3,000. So it's a somewhat useful peak, but not nearly as useful as the alcohol or the carbonyl.